Let me get into multiplier, ma. So since in multiplier also there is more than 16 multipliers are available, but in our case we are going to study only two types of multipliers, ma. One is array multiplier and one is a valence tree multiplier. So why we are concentrating only on these two? In spite of out of 16 we are studying only two. Why? Because these two is more effective and it is more oftenly adopted in all kind of designs. So that is the reasons why in our syllabus we have taken into account this array multiplier and valence tree multiplier. So my question is that what do you mean by multiplier or what do you mean by multiplication you think? Can anyone tell me? Right or wrong? Respond it. What do you mean by multiplication in your view? 2 into 2, 4, 4 into 2, 8, or let's say 2 table, 2 into 2,
Repeated
4.
addition, sir.
Very good. It is a repeated addition. That is the reasons why we are studying about the adders. That is the reasons why we are studying about the adders. Why? Because while you are going for a multiplication, there is no any separate structure for the multipliers or the multiplication. We're going to make use of this off adder full adder structure more effectively to get the operation of your multiplication. So the multiplication is nothing but a process of a repeated addition that you have to be very, very clear. Okay. So in this repeated addition of multiplication process, there are two types of multiplication is possible, ma. One is an unsigned multiplication, one is a signed multiplication. Means we will worry about plus and minus of the given numbers. Let's say for example 2 into 2 both are positive integers. So 2 into 2 is equal to 4. So the output is nothing but your output is nothing but positive integer. That is called signed multiplication. Means let's say if I want to multiply plus 2 into minus 4, what will be the answer, ma? Plus 2 into minus 4?
-8.
Very good. 4 into 4, 2 into 4 is 8. We know that. But plus 2 into minus 4 means we are taking care about the sign changes also. That is called signed multiplication. But when I say unsigned multiplication, it won't care about the sign of your given integers. So that we won't worry about whether it is plus or minus. We'll only do the multiplication. That is called unsigned multiplication. Am I clear, ma? So there is a two category, signed multiplication and unsigned multiplication. So the two types of multipliers what we are going to see like array and valence tree, both are example for the unsigned multiplication. Both are examples for the unsigned multiplication. Okay, right? So with this, let me move on the next one. When I say a multiplier, is that my pen is available? Yeah. When I say a multiplier, these two terms is going to be important. One is nothing but multiplicand. Next is nothing but multiplier. So multiplicand is nothing but on the top and multiplier is going to be available on the bottom. And because of this multiplicand multiplier is going to be get multiplied together, we'll get the partial products and followed by we'll get the product. So product we are indicating in terms of what? P0, P1, P2 and so on up to Pn. That is what the product we are writing. Just you can imagine when you're going to have two numbers of multiplication. Let's say for example 11 into 11. So we are going to do a multiplications. So this is your multiplicand and this is your multiplier. And what about this? These are all the partial products. What is the partial product now? 1 into 1 and this is nothing but 1 into 1. So these are the partial products. This is called a partial product. And what is the final product value? This will be the final product. We will add this. We'll say 1 and we will say we will add this 2. We'll add this 1. So we can say it's going to be 121. So we'll assume this is 0 is available. And here it is 1, 1, it is 2. And we'll assume that there is nothing is available. So this is nothing but 1, 121. So these are the product. That is what it is written here. Are you understanding? Right? So by given integers, you're converting into binary. We're writing in terms of y0 to y5. Means how many bit it is? How many bit it is, ma? 6 bit. Am I clear? Same way, how many bit it is? 6 bit. When I say 6 bit cross 6 bit multiplication, how many number it is available? We have 2, right? So we have 2 bits, two numbers and 2 numbers. multiplication, how much you are getting? You're getting the 3 elements at the output. Same way, when you're going to go, it's going to be 6-bit and 6-bit. How much you're going to get? We're going to get the 11 as your product. That means, sorry, 12 as your product. Is that clear? Any doubt on this? See, x0 will be taken. It is multiplied with every element. x0, y0, x0, y1, x0, y2, x0, y3, x0, y4, x0, y5. Done. As like a multiplication. Then what you're going to take? We're going to take x1 and multiply it with the all the multiplicand. We'll take multiplier of x1. We'll multiply. We have a multiplication with the all the multiplicand. How we can do? x1 y0, x1 y1, x1 y2, x1 y3, x1 y4, x1 y5. Next, we can take x2 as a multiplier element and multiply with the multiplicand. So we can write this expression. Any doubts on this partial products, ma? Any doubts on the partial products?
No, sir.
No. So once you don't have doubts on the partial products, so once you complete that, what we can write? We can write. Now we can write the product. We have to go for addition. So this will be taken as it is. P naught is nothing but what? X naught, Y naught. Then by adding these two, we will get partial product 1. I will add this 2. I will add this 3. I will get partial product 2. I will add this all partial product 3. Then partial product 4, product 5, product 6, not partial product, product 7, product 8, product 9, product 10. And this maybe provides some carry. That's going to be a product 11. Are you getting my point, ma? So a product is nothing but an addition of your partial products. Product is nothing but product is equal to addition of respective partial products. Is it clear about the multiplication, ma? So no one should have a confusion on multiplicand, multiplier, partial product and product. If it's clear, then we move forward to the next one.
Yes.
Right. Like, so with that one, let me move forward to the next slide. Let me have an array multiplier. Okay. So what is it? What is it taken now? Array multiplier now. I have taken. This is your multiplier. This is your multiplicand. Multiplicand. This is your multiplier. And I'm going to do a partial products. How many bit it is? 4 bit. So I can write x0, x1, x2, x3. So let I take laser. Yeah. So x0, x1, x2, x3. And what is my multiplications? Multipliers, your y0, y1, y2, y3. Let me form the partial product. How we can do? We can take y0 and we can able to multiply with the multiplications. x0, y0, x1, y0, x2, y0, x3, y0. We have completed this. Then we can take y1 as the next one. So let me take y1. Let me multiply with your multiplicand. y1, x1, x0, y1, x1, y1, x2, y1, x3, y1. We always know that while you're going to write the next partial product, let me shift from the one left shift will be do from the your LSB. So completed. Let me go for y2. So y2 again we have to take one left from your LSB, from your previous LSB. So let me move here. So what is now we do? x0, y2, x2, x1, y2, x2, y2, x3, y2. It is written. Let me take the next multiplier from your next multiplier for the multiplicand. We can go for that. So we can take one more left shift from your last LSB. So x0, y3, x1, y3, x2, y3, and x3, y3. It's written. Is clear? Now let me go for product. So let me take this x0, y0. There is nothing to add over here. So we can assume that all are 0. So we can directly take it as a product P0. Then what about P1? By adding this 2, x1, y0, x0, y1, we can get P1. Then by adding this 3, x2, y0, x1, y1, x0, y0, we'll get P2. Then adding this 4, x3, y0, x2, y1, x1, y2, x3, y3, we can say P3. And by adding this 3, P4, P5, P6, and this may provide some carry that we are writing P7. Is that any clear on this? Is that clear? Yes, sir. Any doubts, ma?
Sir, when we multiply 4-bit with 2-bit, what about out?
When we multiply
4-bit and 2-bit.
4-bit and 2-bit. Okay, let's say for example 1, 1, 1, 1, and you are saying that you can multiply with 0, 1. Am I correct? Or 1, 1. Yes? I will assume that this nothing is available. I will make it as 0. I will make it equal. I will make it equal bit, ma. Whatever
Okay.
MSB is not available, I will assume as 0. Yes or no?
Yes.
Sir, how come that P7 came like that? It is the carry bit or something else?
It's a carry, ma. Because we're adding something. See, x3, y2, x2, y2, we are adding it. We're getting some sum that may having some carry, right? And after that, this x3, y3 will be a double digit. Let's say, for example, instead of writing 1, instead of getting 1 or 0, if you're going to get 1, 1 or 0, 1, so 1 is going to become this P6 and this 0 is become P7. It's a carry. That you'll
Okay.
understand while you're going to plot the structure. Okay, ma? Any other doubts? So whenever there is a one question was like 4-bit with 2-bit, we will convert this 2-bit into 4-bit. Why? Because when the 2-bit is going to be 2-bit is going to be getting available, the MSBs will be assumed as a 0 so that it will convert it into 4-bit. So the multiplier will be carried out. That is the answer. Okay, ma? Any other questions? If this clear, then we go for structure.
Sir, I have a doubt.
Yeah, please.
Yeah, sir, in array multiplier, is there any use of shift registers?
What is the use of shift registers in array multiplier, ma? Shift registers main function is nothing but shifting the data from left to right or right to left.
Oh, okay, sir.
Okay, ma? Good, no problem. Very good. Shift registers is main purpose of shift registers to develop is nothing but to store the data, one bit of data, and as well as to shift the data from either to left to right and right to left. And it may be it's going to be getting applicable when the multiplication rate is going to be very higher where you want to shift the data, but it is going to be unnecessary point of view to bring the shift register. Why? Because you're going to increase the complexity of the circuit. Adder is going to be very simple circuit for us to go for a multiplication operations rather to make use of the
Yeah, okay.
combinational circuits over here, sequential circuits here.
Yeah, okay.
Am I clear?
Okay, sir.
Right. Good. Any other doubts? Shall we move forward, ma?
Yes.
Yes, sir.
Okay. Right. Just a second. Let me delete this so that we will get clear. Discard. Uh, this we don't want. This we don't want. This we don't want because we will plot it. Then only you will understand. Okay. Otherwise, if it is already available, then you will get confused. Then there is no meaning of showing the already available diagram. Let we draw by ourselves by our own. Then we can. Then only you will never ever forget when you are going for an examinations. Shall we try to draw the diagram for this? Okay. So let me assume that this is going to be my y naught. Okay. And let me have y1, y2, y3 also. So let me have y1, y2, y3. This is your y1. Okay, and followed by, let me have y2. Followed by we have y2, and followed by, let me have y3 also. Okay, so first one, what you are doing, let me take your x naught, y naught, right? So we can say, let's say for example, where is my thing? Yeah, x naught and y naught. So we can say x naught multiplied with the y naught. X naught, y naught. Okay, then what is available? X1. Tell me the logic. X1, y naught. Yes or no? Ma, are you getting my point? What I'm doing? Then y naught, x2, y naught. Here, you check the logic here. This one. Can you check it? X2. Then what I have one more AND gate, that is nothing but y naught. This is nothing but x3. Any doubts on this? Any doubts on this?
Yes, sir.
Please understand the diagram and then draw. Don't mug the diagram. I have plotted for all your multipliers y0, y1, y2, y3. So let me just draw the first one. Then let me take the first one, this one, nothing but x0, y0. So I'm just taking from y0 and given as x0 as an input given to an AND gate, followed by x1, y0, followed by x2, y0, followed by x3, y0. If you are getting confusion, you should write like this. You can write like this here also. You can write this is nothing but x0, y0. This is nothing but x1, y1. This is nothing but x1, y0. This is nothing but x2, y0. This is nothing but x3, y0. No doubts? Okay. So
Yes, sir.
now let me write the next one, because we always have one left shift, right? So I'm not going to draw directly to this. Let me have one left shift from here. So what I'm going to write, I can able to write that x naught y1. Yes or no? So I can draw like this. So this can be one AND gate. This I will give. This is nothing but my x naught. So I will write x naught output. Can you tell me what is the next one? What is this? X1. What is this?
X2,
X2. Very good. What is that?
X3,
Very good. Which I drawn? I drawn this. Any doubts on this?
No, sir.
Right? So let me have one more left shift from here. So what is the one more left shift we can do? We can able to take it from here. So I'm going to draw a plot like this, like this. This is nothing but my x naught. So this is nothing but my x1. This is nothing but my x2. And this is nothing but my x3. Can you complete the bottom portion then? So let me go for next one more shift. So we can plot like this, such a way that this become x naught. Then this become x1. Then this become x2. Sorry for drawing the handicap like this. And this become x3. Where is my pen? Yeah, here is my pen. Yeah. Is that clear? All of you completed? Draw with me parallelly. Is completed so far? Draw with me parallelly, then only you will understand. Otherwise, you will have a doubt. If you are having any problem of understanding, please let me know immediately. I will resolve your doubt immediately. So far, any confusion? Did you draw and completed?
Yes, sir, completed.
Completed. Very good. Any doubts, ma? Just represented by means of diagram. That's it. Now, what is the x0 y0, ma? X0 y0 is nothing but x0 y0 is nothing but what? Your product p0. So nothing is there. Let me take output. It is nothing but product. It is nothing but p0. There is no change on that. Okay. So what is next one, ma? To get P2 what to get P1 what I should do? To get P1 what I should do?
X
And
not and Y
operation
not.
of both.
X not Y1 and operation
X1
we have to do.
Y0 X1 Y0 plus X0 Y1 I have to do. Yes or no? Yes or no? I
Sir,
want
or
X0 X I want your X1 Y0. Okay, X1 Y0 plus X0 Y1 I have to do for addition. Yes or no? So that has to give addition. So this is going to become added. What is adder it is? This is nothing but off adder. Why to off adder? Because there is no carry. So the output of this is nothing but what? Nothing but P1. Agree?
Yes, sir.
Okay. So now, when I'm going to have a off adder, what will be available? The off adder of 2 input is added, ma. Sum you got it. Sum is P1. There is a carry is
Sum and
available, yes or no?
Yes, sir.
Okay, there is a carry is going to be getting available. Right, that carry will go where this carry will go. This carry will go to here, next stage.
Next input.
Yes or no? So that the carry is going to next stage. So what is the next stage we can do? We can able to add. What we can able to add? We can able to add these two inputs. These two inputs along with the carry. Yes or no? Are you agree? For
Yes,
next
sir.
P2, we have to add along. We have to add these two along with the carry of your previous, right? So that we can add these two along with the carry. Then what is the adder it is?
Full adder.
Very good. Full adder. So this full adder output is going to given what? This full adder output is given to output
Sum
like
and carry.
this. And this has to be
X
added
not
with
Y2.
this X0 Y2 so that we can able to add with this. This become
Off adder.
off adder. This output become P2. Yes or no?
Yes, sir.
So this carry will be propagated to next stage. This carry will be propagated to next stage. Yeah.
Yes, sir.
Right. So that if it is the case, what will happen to the next stage? Now with these logics, we can draw easily. How we can draw easily? Because there is carries coming from your previous stage. It's not going to become off adder. It will become a full adder. This has to be added over here. These addition become off adder. The carry is going to propagate into next stage. So this full adder can be given over here. This already one carry is getting propagating from your previous stage here. This becomes full ladder, and this is going to become come out. And this 2 is going to be getting added. What is it available here? Half adder is going to be getting available, and this is become P3, and carry is propagating to next stage. Carry is propagating to next stage. It's clear?
Yes, sir.
If you mark the diagram, it is very difficult. Now, how many input is available now? This is one input.
2 inputs.
This is one input. Then what is the adder it is?
Half adder.
Very good. Half adder. And what about the carry? Carry is coming out. Okay. Carry is coming out. So this sum will be going to here, and this is going to become full adder. Why? Because this carry is getting propagating. This is going to be come out over here. This is going to become full adder, half adder. Full adder. Full adder. And what is the product it is? P4. So this is going to be getting propagating to the next stage. This is going to propagating to the next stage. So what is it available now?
Full ladder.
Full adder.
Yeah. Why full adder?
Because there is one carry.
One
of
carry
half
from
adder.
other.
Very good. This carry is going to be getting added over here. This become full adder. Right? So these two will be coming here, and this is become what? Full adder once again. Why? Because this carry is getting propagating here. This is become what? P5. P0, P1, P2, P3, P4, P5. Yes, P5. And this carry is going to be getting available.
Ladder.
Right. So this will be given to here. This is become full adder. Right. This carry is going to be getting propagating. This is going to be output. This has become P7. This carry is going to get generated. This has become P7. It's clear?
Sir, in this diagram, we have taken the main line as y1, means y0, y1, y2, and y3. We can switch it with x1, x0, x1, x2, x3, and we
Nothing
can.
wrong. Nothing wrong.
Okay, sir.
Okay. Anyway, we're going to do addition operations, dear. No need to worry about it. We are doing summative addition only. Since we are not going to make use of any kind of a combination sequential logics here, there is no meaning, there is no matter if you're going to switch over. Am I clear?
Yes,
so
sir.
my suggestion is nothing but don't try to mug the diagram, try to understand and then draw the diagram so that you never ever do the mistakes on the diagram. Am I clear?
Yes, sir.
If there is no doubts, we can move to the last topic. So this is your array multiplier, ma. Okay, this is your array multiplier structure. So in examinations, if they ask you about the array multiplier, we should draw the structure like this. Okay. Shall we move forward to the last topic?
Yes.
Yes. Okay. Done. So if it is the case, so I strongly believe that you won't mug the diagram. You will draw the diagram by yourself. So kindly have a practice of it. So next is going to be the velocity multiplier, ma. It's one of the fastest multiplier in your architectures. And in this case, why they ask you to do why they are claiming that it is a fastest multiplier in the sense, in this multiplication process, they will try to reduce the partial products. Okay. In general, we always have partial products like this, right? But in this case of the velocity multiplier, they always try to reduce the number of partial products so that the addition operation is going to become more faster when you're going to compare with your other multiplication process. So in order to do reducing the partial product quantity, they're going to make a different kind of a step-by-step procedure to complete this value stream multiplier. So that you have to understand very clearly one by one. So let me go through one by one like that, so that you will clearly understood how it is going to be happen. And if you are not going to understand that, you kindly stop me and please let me know where you have a doubt. Shall we start?
Yes, sir.
Good. Let's consider this. I am going to have a multiplication with B3, B2, B1, B0 and along with the A3, A2, A1, A0 or vice versa, whatever it might be, you can consider. Now, what will be the partial products generally? Write the partial products. Please kindly in the notebook, write the partial products for B3, B2, B1, B0 into A3, A2, A1, A0. Kindly do along with me. Then only you will understand the value stream multiplication. Once you wrote the partial product, please let me know so that we just move forward. So far you have be very passionate, and if you this also if you're going to be more passionate, then you will be understand very clearly. Is it written, ma? Partial products is written. How will write the partial product, ma? Take 1 and multiply with everything. A0, B0, A0, B1, A0, B2, A0, B3. And have one left from your LSB. We can take A1, A1, B0, A1, B1, A2, B2, A3, B3 like that. Did all of you got this?
Yes, sir.
Yeah, very good. I think all of you got this partial products and you have written. Now, please kindly closely follow the step procedure. The next step procedure is nothing but you can see these three, you can see these three where here nothing is available. It is empty, right? In a value stream multiplier, after writing the partial product, step 1 is nothing but writing partial product. Write down. Step 1 is writing partial product. So once your step 1 is completed, let me move forward to step 2. In step 2, what we'll do, we'll try to move on unoccupied space of the partial products. Like for example, this fourth one, check out this. There is no partial product on the top. You try to make a move of this column into top towards from the initial line like this. Are you getting my point? These three will try to move on here. So that I will start to write A1, B3, A2, B2, A3, B1 like this. Same way this will become A3, B3, A3, B2 and here will be empty. And this will become A3, B3 means it will like this. Are you understanding? I'm just pushing this fourth one into top. Push this fifth one to top and push the sixth one into top. Any doubts? Is it completed, ma? Any doubts here?
No, sir.
Ma, completed?
Yes, sir.
Right. Any doubts so far, ma, in the step? So step 1 is writing the initial partial product. Step 2 is nothing but from the point at which there is no any top layer is not available, like from 4, 5, 6, we'll try to push it from the bottom to the top so that we can pull this A1 B3 to the top level equal to A0 B3. So we can write A1 B3, A2 B1, A3 B1. So this space become empty. So that we can write A3 B3, A3 B2. This space become empty. So we can write A3 B3. This space become empty. So if you're going to do mistakes on this stage, then your entire product, your entire structure is going to be wrong. Make sure you have completed this without any understanding problem. Shall we move on? Shall I move on, Ma?
Yes, sir.
Okay. Now you look at this. This will give you some kind of tree like a structure. This will be a bottom of the tree and this will be a top of the tree like a triangle, you know. That's what I have drawn this a particular dotted line for you to be understanding. Like a tree, like a structure, it's like a top of the tree, it's like a bottom of the tree, but it is an ulta. That is what the way in which it is available. Now, please do understand and please closely follow. In this valence tree multiplier, after reforming your partial product like this, now we will select the initial structure of your partial product from a top of the tree. That means from the center of the tree. I will select this. First, I will select this at top of the tree, and after that, I will select the left hand side of the tree. Means I will combine these two together one, and after that, on the left hand side, I will combine these two together as a one. So I'll write this is a first block. I like this is a second block. Any doubt on this? I repeat, once you complete your completion of this process, it looks like a weird tree structure. In after forming a tree structures, we have to construct block segregation. In the block segregation process means block segregation means we have to identify the adder blocks. How the adder blocks can be getting involving. To identify your final adder blocks, we will start from the top of the tree from the ulta, where let I just combine these two as a single adder block, and from the left hand side I will select these two as a combined block. We should not move on to the right hand side because that is a step-by-step procedure. It is involved on the valence tree. You can move on the first, you can select the top one, then from the left hand side you can select the next bottom one, so that I can select these two blocks here. Is there any doubt on this? Any doubts?
No, sir.
Okay.
No, sir.
Right. If I'm going to add this is a two variable. If I'm going to add this, what adder it is? Half adder or full adder? This is addition. This is additional block, ma. This is adder block. Is it a half adder or full adder?
Half adder.
Very good. What about this? What about this?
Half adder.
Very good. Only you concentrate on this block. Don't forget about the remaining things. These two are half adder. These two are half adder. So I can say that this is half adder. This is half adder. Any doubts on this?
No, sir.
Very good. Let me move on now. Now see there. Now let I do as it is A0 B0. Let me just down as it is A0 B1 A1 B0. Let me write as it is A0 B2 A1 B1 A2 B0. Let I write A0 B3 A1 B2. What is the output of this half adder one? Sum one. Yes or no? Are you agree? Please
Yes,
listen
sir.
very carefully. A0 B3 I am writing as it is. A1 B2 I am writing as it is. By adding these two, since I am just assuming this is half adder one block, this is half adder two block. The half adder one block output is nothing but sum one. Are you agree? Are you agree this?
Yes, sir.
Okay. Once sum is available, where the carry will go? Carry will go to next stage. once sum is available, this sum is will go to, the sum will be taken out and the carry is going to the next stage. So I can write carry 1 because of this sum. Let me have a carry. So I will write carry 1. And what about your, what about this number? A1B3 is A1B3 as it is. Then because of this 2 addition, what will happen? Sum 2 will be available. I will write S2. And because of S2, what will happen? Carry 2 will be available. So I will write carry 2, A3B3, A3B2, then A3B3. Any doubts on this?
Sir, can you explain the carry 1 and carry 2 part once again?
Okay, ma, just a second, no problem. If it is the case, I will explain, no issues. Let I take a pen. Okay, so that you will understand. Right. So we decided that this is my first off order block. We given number as, this is off order block 1. So this is the second off order block we have decided. So we can give a number as off order 2. Okay, ma? Now, what will happen? This off order 1 will have, this off order 1 block will have sum 1, carry 1. Correct? Why I'm writing 1, 1 in the sense, off order block 1, I'm writing sum 1, carry 1. No, there is no other meaning behind that. Is it clear? Off order 1 block.
Yes, sir.
It will produce sum 1, carry 1. Same way, off order 2 block, it will produce sum 2, carry 2. Okay, va? So by that scenario, what we are doing, I'm writing here, this we are writing as it is. We can say A naught, B naught. This we write as it is. A naught, B1, A1, B naught. This we write as it is. A naught, B2, A1, B1, A2, B naught. Am I clear, ma? Then now we are going to write this. What we will write? A naught, B3, A1, B2. Instead of writing this A2, B1 because it is HA1, I will write the sum. What is sum? HA1 sum is nothing but S1.
S1.
So once I have S1, carry is available. Where the carry will go? The carry will go here. Yes or no?
Yes, okay.
So I will write
Yes.
carry 1. Then I will write A1, B3. Then what is available? What is this HA2 will produce?
S2, sum 2.
S2 will produce. The once S2 is producing, your C2 is going to be getting available. Where the C2 will go? Here will go. So how I will write C2? I will write A3, B2, then A3, B3. Then what we will write here is nothing but A3, B3. Is that clear now? Is that clear?
Yes, sir.
Yes, sir.
Right. So don't get any confusions on this, please.
Sir, I have a doubt.
Yeah, please.
Why we are considering half adder as A2, B1, A3, B0? Why can't we consider A2, B3, A1, B2?
The person who identified this Wallace person, he given that significance while you're starting from the top of your tree, we can able to start with the, we can able to end with the minimum number of full adders and half adders. That's what he proved. When you're going to start with the top of the tree, we can able to complete with the minimum number of full adder block and as well as half adder block. And moreover, while he's starting with the initial, he can start with the, let's say for example, when you going to start like this over here, we can't even introduce the half adder, yes or no? And same way, when it is going to be starting with the regular procedure, the number of half adder is getting increasing as well as number of full adder is getting increasing. To avoid that, he's starting from the top of it and that to be with the half adder. That is the reasons behind that. Am I clear, ma?
Yeah, yes, sir.
Right, ma. Ma, any other doubts, ma? Shall we move forward? I think now you don't have any doubts on these steps.
Yes, sir.
Shall we move on?
Yes, sir.
Right? Now, watch it very clearly, very closely. Now we can just move on this. What is this now?
3 full
This
adders
is,
and one half
next we
adder.
can combine these two. Half adder 3. Okay. Then we can combine this. What about this? Full adder. This 3 is full adder. This 3 are full adder.
Yes, sir.
Am I correct? See, these two we are not disturbing. Why? Because we know it very clearly. Why? Because this is will take it directly. This is going to become half adder. That also we know very clearly. We want to simplify the remaining complex partial products. That's what we are doing now. Are you getting my point?
Yes, sir.
See, I'll just try to do this. I'm combining these two. This is become an half adder block. So what is half adder block number now? Already 1 and 2 is available. Let me make 3. Then I can combine these 3. What about these 3? 3 inputs are available. So it's become full adder. Block number 4. And when I'm going to combine these all, this has become full adder. What about this? Block number 5. I'm going to combine these all. It has become full adder. What this thing is going to be? Block number 6. Now, can you write the next partial product? Can anyone write next partial product? Is there any clear? Is this clear up to here?
Yes, sir.
Right. If it is clear up to here, can you write the next product, partial product? Try it. We are almost approaching last step. They're going to be end. If it is clear, can you write your next partial product? Do remember here what you should remember. HA3. HA3 will have S3, C3. Am I correct, ma? FA4 will have S4, C4. FA5 will have S5, C5. FA6 will have S6, C6. But keep this in mind, write down your next partial product. If anyone is ready to tell me, you can tell it now. We can write as it is, yes or no?
A naught,
Right?
B naught.
A naught, B naught. Very good. A naught, B naught. Then
And A naught, B1, A1, B naught, as it
A
is.
naught, B1 and A1, B naught.
B
Very
naught.
good. Then
And A naught, B2
A naught.
and S3.
A naught, B2. Then it is become
And S3. Yes,
very good. Very good. S3. Very good. Then
Then C3 will be carry on the next and S4.
very good. Very good. Very good.
Then C4 the carry and S5.
Very good. Very good. Then
C5 and S6.
very good. Then
And C6 and A3, B3.
very good. Very good. What about the others? Is that clear?
Yes, sir.
Yes, sir.
So I can write like this. That's what you did it now. Right. Now, after writing this, I hope all of you wrote this without any doubts. Now, let me combine the remaining things. What was this? These two?
Half adder, sir.
Right. Off adder. We can combine these two off adder. What about this? These off adder will have a sum because HA7 will have S7 and C7. Where the C7 will go? Where the C7 will go?
A2, B2, S3.
Very
Yes,
good.
A
So
naught,
what
B
is this
naught.
then? What is this then? This carry will propagate to next level. So we can write this is nothing but my full adder. This is my full adder. This is my full adder. This is my full adder. This one is my full adders. Yes or no? I'm sorry that I just clear my write-up, that there won't be any congestions in the slide. Yeah. Agree this?
Yes, sir.
So this is going to be my final partial products. What is the final partial products here? Is nothing but P0, P1, P2, P3, P4, P5, P6, and P7.